Welcome, everyone, to today's presentation by Ericsson Enterprise Wireless Solutions and technology advice on Waves and Wheels, how cellular networks keep transit agencies moving forward. Oops, sorry. My name is Corey Knowles. I'm managing editor of IT here at Technology Advice, and I'll be your moderator today. We're thrilled to be joined by Daniel Dubieff. Daniel is a senior sales engineer at Ericsson, as well as Russ Matichak, who is a network engineer in King County, Washington. In today's talk, they'll be discussing how King County used cellular solutions in buses and water taxis to reduce downtime and streamline operations. Please join me in welcoming Daniel and Russ.
Excellent. Thank you very much, Corey. So I guess today we're going to be just really overall talking about multi-connectivity solutions in use in public transit systems. So it's a very heavy topic, easily identifiable with public safety, but public transit is a completely different animal in that space. Less mission critical, at least to some common values here. But we'll just go ahead and dive into the different solutions that are available to us with today's technology. Really quickly, we'll just dive into the next slide that talks about what's available to us in a public transit vehicle. Now, contrary to some public safety stuff, we don't have license plate readers and multiple cameras, but there are multiple systems in a bus that take advantage of the exact same technologies. So we do have AVL telematics, which is the telematic information coming from the vehicle bus, as well as GPS positioning to help with applications that riderships may use for tracking where their next bus is coming, how long they have to wait, did they already miss it. Wi-Fi infotainment systems as well that provide for some guest ridership applications where they can use the Wi-Fi, not present in all systems, but it's an available option there that's shown. Farebox. This is where the payments are collected, whether it's a subscription for the bus ridership or just an on-demand payment system with a credit card. Rider tablets, digital signage, in-vehicle connectivity for for safety purposes in regards to camera systems, both for the driver and accountability for anybody who's on board. And of course, the storage for that in the digital video recorder. And then, of course, any additional computing systems that may be eligible on that bus. Russ, anything that I might have missed in
no, that covered it pretty well. Yeah, that's some of the bigger things that we've done is like for the one bus away for tracking, so people know when their bus is going to show up, and then we can present that information at the stop. One other thing we do is use it for signal priority. So when a bus is approaching some intersections, we can request that they either hold the light a little longer or turn it green sooner, just to keep the flow and the bus on time.
Of course. And that takes quite a bit of synchronization too. So you have your GPS updates, but then you also have to transmit that to a backend system to make sure that that's all synced up. All right, so moving on to the next one, we'll cover the different types of options that we have for maintaining the connectivity purposes here within the buses. So your most common deployments are going to be a single router, single modem, and you may or may not have one or two carriers. Now, you have the option, of course, in the Cradlepoint platforms to run dual SIM. Now, single modem with dual SIM does give you the ability to prioritize your carrier of choice, in this case, carrier A versus carrier B. SIM slot 1, carrier A, SIM slot 2, carrier B. Now, when you're traveling through your dispatched route, if there is any issues with that carrier, whether it's an outage or just simple signal coverage issues, the device in this case would then be able to transition, fail over to that second carrier, and continue on. However, the time that it can take for this transition to occur can be quite extensive. Varies anywhere from 60 seconds all the way up to 5+ minutes. So during that downtime, you're not able to take any fare transactions. You're not able to send those updates to that traffic signal prioritization system or updates to the CAD or AVL that the vehicle is reporting to. There may also be delays in any onboard, digital signage advertisements that may also be geo-based in their deployments. So this is just one of the drawbacks that you would have in this particular dual SIM system. One way to alleviate that, of course, is to move over to a dual modem solution. And this would allow you to actively have both a primary modem that's active with carrier A, but then a secondary carrier that's active online with carrier B. And that opens up quite a few doors for how you can utilize these two signals, these two paths to the internet, or just an egressing WAN for your solutions and implementations. Now, I think one piece that I failed to mention on the prior scenario, the single modem dual SIM, is the behavior when you are, now in the case of a cradle point, we prioritize SIM 1 over SIM 2 or carrier 1 over carrier 2. Russ, have you run into any issues with regards to how that could be problematic in some situations?
Yeah, with the single modem dual SIM, it's always trying to get to its higher priority. So if the higher priority LTE is not reachable for some reason, it's slipped over to the second one, it'll periodically have to load the firmware back to go to SIM 1 to try to see if connection's there again. It doesn't have any way visibility to see that and check it, so it will toggle back and forth.
Understood. Yeah, that's quite a nasty drawback. You've got not only do you have the transition time from SIM 1 to SIM 2, but then you have to wait for it to go back, only for it to show that there's still no connectivity in that scenario. So yeah, definitely one benefit there. And we'll move on to the next one and just kind of outline one of the available solutions that we had done with King County. And Russ, I'll turn it over to you so we can kind of discuss what challenges you faced and then what solutions you were able to adopt when you transitioned over to dual modems.
Yeah, we have two setups. So for our tech pylons, we have the single modem, which is fine because it doesn't move around. So we can pick from the different SIMs. We can either have, one carrier, FirstNet, say, or T-Mobile, or any of those, and select and change that based on where its location is, but it's static, so it stays there. For the coaches, as they're moving, having a design with the dual SIM, dual modem helps out because if they're both online at the same time, so it can always, the cradle point's monitoring which is the better signal. If one of them should drop out, it just seamlessly transitions over to the next modem, to the next carrier. And then it'll try to go back for the priority, but there's no dropout, there's no time because they're both active at the same time.
Excellent. And then with regards to you having dual active modems, are you doing anything to define what traffic goes over any specific interface?
Yeah, the other thing we can do is we can prioritize, so we have video that we're recording. If we need to look in there real time, we can direct it to one SIM over the other. That's sometimes used for the different agencies that are in charge of, the security or something. We can direct it over a specific modem, how we want that traffic to go.
Excellent. All right. And then furthermore, we do have a secondary solution that we've worked out with you guys regards to your ferries. Now, these are waterborne taxis. Definitely not your typical scenario, and there are some definite challenges that get posed when you're traveling over water in regards to cellular connectivity. Can we discuss a little bit about what challenges you faced there and how you were able to address those?
Yeah, for the water taxi, we had a cradle point, but that's mounted inside in the wheelhouse. So we have, large, thick coax cables that go up to the top outside for the antenna. We were trying to get full-time coverage across the water. It seems like out in the middle, we kind of drop out. And so we're going to upgrade the hardware, but the challenge with that is just adding additional antennas and the coax and the loss and stuff like that. So we use the 5G, the 2105 router. It's able to do captive modem. So it has a signal and everything's all encapsulated in the unit right up outside, so there's no signal loss as far as the cellular side of it, and then it converts it to Ethernet and runs it down into the bridge there in the wheelhouse as Ethernet. And the advantage of that is there's no signal loss at that point, and we turn that into a captive modem. So as far as the cradle point is concerned, it just sees that as another modem. It doesn't know how that's working, or that it's actually another router. So that's really helped out in being able to connect full time. We have a lot of the maintenance applications and stuff that the staff needs to have real-time connectivity, and it's really given us better signaling and higher speeds for that.
Excellent. Yeah, you've brought up a huge point with any installation, whether it's in vehicle or an a static site, is the cabling requirements when you are running external antennas. We're talking about a cellular modem that's 5G that has 4 connections on it. And if you're running 4 external coaxial cables, any length of distance, the frequency range here ranges from 600 megahertz all the way up to 6 gigahertz. And over the range of something simple like 15, 20 feet, you're going to have some extreme loss unless you're using the proper cabling with enough shielding. And the cost that surmounts to that when you're running 1 modem, which is 4 connections, versus running 2, which is up to 8, can be quite costly. And so running a single, in this case, we used our R2105, which we'll cover here on a future slide, which has a single Ethernet handoff but embedded antenna. So all the compute, all the routing, all the modem connectivity is mounted right there where you can get it best up there on that mast. And then all you're running behind that is a Ethernet connection, which by the standard can go up to 300 plus meters without any degradation of signal or anything. It's at that point, it's an Ethernet connection and handoff. So it's fantastic. Not something that a lot of folks realize whether it's a ferry like this on a water taxi or in a bus, navigating where your electronics components are installed versus where you can mount the antenna up on the roof. We have electric buses, we have buses with propane tanks on the roofs. It's really good to be mindful of how exactly to better that signal where you're going to be routing antennas, let alone anything internal such as Wi-Fi if that's provided for your ridership. Alrighty, we'll go ahead and move on to the next one. We'll cover a couple of the platforms that are available from Cradlepoint and how they're utilized in these particular scenarios. So firstly, we'll cover that first modem that you mentioned, the R2100, and that's available in 2 variants, the 2150 and the 2105. I'm sorry, the 2155 and the 2105. The variation there is that one has Wi-Fi, one does not. And they're both externally designed to be mounted up on the roof. All the compute, everything, these can be a standalone router, broadcasting their own Wi-Fi, connected up to 5G with an Ethernet handoff within the vehicle as well as GPIO. Or it can be designed as the use case that Russ mentioned here with the water taxi as just a singular modem attached to a controller such as the R1900 or the R980. And in that scenario, it's an Ethernet handoff to that device inside the cabin where the electronics can be safely stored within their electronics cabinet. And within the UI, within the configuration of the 1900, it is seen as simply an additional modem that's directly attached. So it really simplifies the way that you prioritize these within our connection manager, which is the tool that's used to prioritize carrier A versus carrier B, all the configuration checks that you can use to validate that those signals are up and usable. All right, and then so the 2105 is our roof-mounted ruggedized router. The R1900 is our top-end 5G device. It does have an option for running dual modem natively on the unit, as well as incorporating Wi-Fi 6 and Bluetooth within the cabin. The R980 is a more recent announced device that is a much smaller form factor, 5G supported unit, and that one does not support dual modem outside of the 2105 add-on, but it still gives you dual 5G as well as Wi-Fi 6 within the cab. And then the R920s and the 1700 are our LTE supported options, both supporting dual modem. The 920 does have an additional dock that mounts on that allows you to utilize a secondary carrier, similar to how you're utilizing it with the 1900 or the 1700, whereas the 1700 is an all-inclusive housing, and there's a door that slides in a modular modem to add in that second carrier solution. So regardless of how you want to have this, have your ridership covered or your needs met, there is traditionally a Cradlepoint platform that can help you get there. All right, so we'll just cover a common deployment, I would say, on how this would ideally be deployed in some of these applications. So your traditional bus with a R1900, in this case, this one has a PoE dock. So this is an additional attachment that powers up to additional 4 devices that support either BT all the way up to BT, a 60-watt max budget on the PoE. We have customers using this for camera systems, using it for the additional modem. Really, the sky's the limit. This gives you a full 8 ports of Ethernet. And then of course, the antenna for the internal modem is also routed up to the roof. But you can see there's a couple of configurations here for having both an external Wi-Fi. Maybe you're connecting this up to a depot Wi-Fi access point infrastructure, or maybe in some cases, some cities and counties do have a metro Wi-Fi solution available that they may want to augment instead of cellular. And then Wi-Fi, of course, being broadcast internally for use by either the driver or the ridership. One common thing that I run into a lot, Russ, is power connectivity to this. There's usually the bus driver, when they leave for the day, they hit a master switch, and that kills every electronic component in the bus. Our recommendation, of course, is to run that on ignition sense. Is there a particular reason in some of those cases where you've seen where you absolutely have to kill everything versus allowing a device to trickle battery in that case that's used every day?
No, that's a very good point on the ignition sense. Yeah, we have that set up because we have other devices that offload. So basically the driver logs off of the system and then turns the bus off. But the other equipment has logs and other things that it needs to update, or maybe there's a firmware update for one of the onboard AVL systems. And also if there's any need for video offload when the bus gets back to base. So we definitely want to have that on. We have it on for like an hour after the driver shuts it off, just to make sure everything can offload, but then it shuts itself down so it doesn't drain the battery on the bus. Perfect.
That's excellent. And then you actually covered the other topic, which was connecting up to any sort of depot Wi-Fi, and that for your purpose, that was for offloading the video. All right. Anything outside of this generic, anything that you wanted to add, or for the folks that are listening on when designing this, any considerations to take in outside of maybe the coax that we discussed earlier that they might want to be mindful of when you're planning a deployment and installation of an in-vehicle router such as this?
The one thing I did want to point out is that, with our current deployment with the dual modem, we have a single antenna that has both for the internal and external modem. On our next design, when we do our refresh, we're going to separate those off because of the higher cable count, but also it'll allow the separation so we could have, say, the same carrier on different modems. Our original design, we had assumed that we would have one carrier on the internal and one carrier on the external, but we did find some use cases where we may want to have both carriers on, or the ability to have both carriers on either modem, and that separate antenna will allow that separation we need.
Beautiful. Yeah, it's there are antennas out there that have multiple elements, designed to with some separation inside to run a fully outfitted cradle point in this particular case. And as we discussed with the water taxi scenario, you have at least 8 RF connections coming off of a single dual modem R1900 for just the LTE cellular, and then you also have 2 additional for Wi-Fi. You have an additional one for GPS. And if you're routing Bluetooth out externally, that could be another connection. But yeah, these antenna housings, you would actually get much better connectivity if you were to separate those. Or you may have a physical requirement where you're routing all the cellular connectivity external, but you have the Wi-Fi internal. So yeah, good information to know. And then the separation point, rule of thumb is usually about 18 inches between your modem antennas. It's still pretty good common to use the all-in-one for a single modem, because usually they're designed for that purpose with enough separation. But running 2 carriers, and in your scenario, you mentioned running 2 of the same carrier. Well, the only problem there is that you have then both elements on the roof, probably on the exact same frequency band, competing with each other, and just adding on to that interference. So thank you very much for bringing that up. And then we'll let's just compound on what we've touched on here. So with dual modem, we offer the availability of, or high availability versus a failover scenario. So you have, if your carrier 1 goes offline, your connection on carrier B is immediately ready to go, if not already working for you before you notice it. Now, we do have some available features that help you take advantage of which carrier to use, especially in scenarios where maybe you don't have horrible coverage across town or across that particular route, but you want to make sure that the platform, in this case the Cradle Point, is using the best available carrier at that time. So we do have a solution called Smart WAN Selection, which allows you to define additional criteria, not just is the connection valid and viable, but which one is better out of the two. So you can define additional criteria such as jitter and latency on the connections. So maybe if you have, for example, one agency that I'd worked with in the Bay Area of California, they had a requirement for a voice over IP line, and they wanted to make sure that the best WAN was available to us at any particular time. So they set a criteria for the WAN that was available with the lowest latency and jitter to be the four most used WAN in that particular scenario at all times. That way, anytime that driver picked up their phone, they would have the best connection available. And then, of course, we have additional features such as load balancing. Now, think of load balancing as opening up additional lanes of traffic on the freeway. So you have two carriers, and they're both connected. You can utilize them both for that same purpose. If you have, again, ridership, you're providing them Wi-Fi, and you don't want them to be all limited to the bare minimum of what is available. But you also don't want to have, you don't have the need to offer them full streaming support or anything along those lines. But you don't want it to detriment any other services that are running on that bus. You can also load balance that traffic to go across both carriers. And then, of course, you can dedicate bandwidth to those applications. So by way of either a layer 7 analytics and knowing what that traffic flow is, you can define information by what the port destination is, the port sources. If you want to say everything from the camera DVR, for example, only goes out via the Wi-Fi, you can dedicate the bandwidth and force that traffic steering to go out to specific interfaces. And then, of course, with our new NetCloud Exchange offering, you do have the ability to bond and aggregate certain traffic, so to utilize both of those links simultaneously in either a resilient capacity to where we're duplicating packets and making sure that that packet gets to its destination. One use case that I'd like to bring up is the traffic signal priority that you mentioned. Here in the Boise area, we actually had a transit system that was overutilizing that traffic signal prioritization. So their buses were not getting the positional updates, and they were actually overtaxing that system to the point to where the county was actually going to push them off. So us correcting and helping them address their cell connectivity issues actually mitigated them not losing that particular feature and function, which I'm sure to many of our presenters and viewers today would be detrimental to their operations. All right. And then let's touch back on, just confirm what we've already discussed. So we have an understanding of what can potentially be covered on here in the bus. Now, Russ, really quickly, in your experience, I know one thing that we didn't really talk about is devices or solutions that may be in that bus that have their own SIM cards. I know I've come across a few where the signage, I'm sorry, not the signage, the fare solution, for example, they may sell that solution with their own SIM card and not allow you to tie that in, or maybe a tablet for the AVL provider may have their own SIM and connectivity options for the riders or for the drivers to log in and track their routing. Any experience on that end that they may want to chime in on?
Yeah, some of those vendors do offer that, and they want to use their SIM and their modems. The advantage of using it through the Cradle Point is that we have it's tied into the back end, into the network, so they get direct connectivity with the security and everything that goes with that. Whereas if they have their standalone tablet, they have to have either dock it later to update any county backend servers, or they have to do some kind of a VPN connection, which we don't really have set up. So their only option would be to connect or dock. So it's very advantageous to have them directly connected in because they get direct backend connectivity.
Excellent. All right. And then additionally, let's, I mentioned this before, the Smart WAN selection. So this is a slide just depicting exactly how this can be utilized. So for example, when we get into a traffic steering scenario, we can force it to go over any of these interfaces. But Smart WAN selection will actually redistribute or redefine what that default route is. So if you're in an LTE scenario, you think of your latency usually common to see latency in the 100 to 60 milliseconds range, which isn't horrible, but it's not also not the greatest. But when you get back into your Wi-Fi infrastructure, that latency can drop sub 20 milliseconds. And so in this particular case, if we were favoring latency and jitter as our defining criteria, once we get back in a station and depot, all traffic would then be dumped over to use the Wi-Fi, or at least the defined ones that we specified to use that route. So really one of the beneficial options that we have here on the Cradle Points. Alrighty, and then just a couple other features that may be beneficial. I know some agencies will have, of course, their own. For one, you may have dual carriers or just a single carrier, and you don't know exactly, maybe don't know how to make the decision on making the transition to dual carrier versus a single. So with our some of the cellular intelligence that's provided with the Cradle Point solution through our NetCloud Manager, you're able to actually log and categorize all the connected cellular modems throughout your fleet, how they're driving out through the day. And now we've all seen the reports from carriers on what their coverage looks like. This is real time, your own routes, your own equipment, what the signals are looking like on a day-to-day basis, constantly updating as the vehicles are driving around. So very useful for identifying if there's really any dead spots, or if you are in the stages of identifying, what carrier is most ideal for our location coverage from a coverage standpoint, versus, who has the better bill, that kind of thing. Helping you make those decisions is, of course, a benefit of using the cellular coverage report here within the NetCloud Manager. And then, of course, if you do need some additional asset tracking, we do have some light AVL featurettes within NetCloud Manager. So historical breadcrumbing, letting you know exactly what route that vehicle had taken, what time of day, etc. Just very not as robust as an AVL solution, but available to you nonetheless with our location tracking. And then, of course, basic device location, which is more on the where is that asset at that particular moment in time, when it was last updated, etc. And of course, other key features that are available to you with this information is the ability to send alert notifications when it enters or exits such a specific geofence, anytime that a location change has occurred. So if you actually have the vehicle moving versus being stationary, if you are in a dead reckoning situation where the GPS cellular signal has been lost, but there's an onboard sensor package within the 1700, 1900 on that discrete GNSS chipset that allows you to continue estimating your location. Very useful if you are, for example, here in Boise, we do have some underground stops for a downtown station that allows those buses to still maintain reporting even though they've lost their satellite GPS feed. And then, of course, the ability to report your GPS signals, whether it's a NEMA tape sentence or custom for that matter. We do have a couple agencies doing that to any third-party AVL CAD provider for your routing and management needs. Outside of this, I think that's it. Anything to add, Russ, that you can think of before we move on to our Q&A session?
Yeah, I was going to say, so these coverage maps are great for, like you said, for checking for coverages and just to kind of verify the carriers. With construction, towers get added and removed. And so it's nice to kind of run those and get an overview of, like, if we have any major coverage holes that we can see that we might need to mitigate with either dual carrier or, routing. And then the real-time maps is good, just so you can see a bus, whether, you need to know when it's going to come back or if it's close to the base or where it's actually located. In case they're having some issues, you can kind of real-time troubleshoot that. And the GPS sentences are good. We do have our video system that the Cradle Point pushes its sentence out so it knows where it's at for its metadata.
Oh, excellent. Yeah, I can imagine that the geofencing alerts definitely help some folks in maintenance know when those buses are finally back on site. All righty. Well, Corey, I'll hand it back to you then here for our Q&A session.
That sounds great. Thanks so much for the presentation, Daniel, Russ. Super interesting to learn how that works, and something you don't think about when you pass city vehicles, emergency vehicles, just going down the road every day. We have a few questions to get us kicked off here already. Let's start here. How has this solution optimized your operations? I believe that's a question for Russ.
Yeah, that's helped out as far as optimizing that is, we know where the buses are, we know where our fleet is, so we can do that through the GPS. It's also put real time on there. We don't have to string infrastructure like prior to the cradle point and LTE. You know, if we wanted a bus to connect while it was en route, we would have to have some kind of a Wi-Fi or other external connectivity. So it was kind of expensive to have to build that out. We can utilize the existing LTE infrastructure now and have buses real time for traffic priority, fare collection, things like that.
That's interesting. So is there what are you looking to add in the future that will maybe help the ridership experience?
Probably the more solutions as far as like fare payments, instead of having to tap a card, maybe some cell phone applications, things like that. Also, just enhancing the experience, just give them more options for the fare and paying, things like that. And also enhancing the scheduling so they know more accurately when their bus will be arriving.
That makes sense. So how has technology on the bus and in the stops been used to help with passenger safety?
We have safety as far as like a video system. So now we're upgrading our video system so that it's more real time. So we can have emergency people actually log in and look at the bus cameras real time if there's a situation. Also, that data is being recorded and can be automatically offloaded if needed. We don't have to send somebody out to pull out hardware anymore to get that. As far as at the stops, we have the capability now if they want to put cameras, right, safety cameras or things like that at the actual stop with maybe a panic button if they need to get hold of emergency people right away. Well, with the cradle point, we would have the ability to do that.
That's fascinating. I'll be darned.
Yeah, you bring up a good point on the emergency button, and I do want to kind of point out one thing that we didn't. Now, this is public transportation. One thing we didn't really cover on is also the use cases surrounding, school districts, public transportation. So similar to the fare boxes and such, you also do have a lot of bus agencies that are deploying scan-in cards for the students to log in and write and identify that they're on the bus, enabling parents to be able to see that, hey, their kid got on at this particular stop, they got off at this stop, or that bus is running behind. So just being a conduit for providing that connectivity piece. And then to your point there, Russ, in regards to a panic button, that's just a simple utilization of the IOs on the cradle point, or in some cases, we've had requests to, when that button is identified as being pressed, to send out a packet of information that's custom, unique, proprietary to that agency, which may just contain, who the driver is, what the position is, the last known, GPS position, etc. Send that payload over to, that way they have a alert notification with an asset tag and position of when that incident occurred.
Oh, wow. It seems like there'd be a bunch of applications for that in the long run, as far as various sensors and whatnot go for crashes even and things along those lines in the future.
Right.
Nice. Well, everyone, please make sure you've taken a minute to download the handouts that are provided. There's some great stuff in there that'll be good takeaways from today. Daniel, where can people go to learn more about Ericsson and what you all are doing with it?
Ericsson.com.
All right. Easy enough. Well, everyone watching, we hope you found the session today valuable and informative. If you have any further questions, would like more information, please just reach out. Once again, thanks for joining Ericsson and Technology Advice today. Best of luck on your quest to streamline operations.
All right. Thank you very much, everybody.
Thanks.